Atom. The atom, basic atomic structure. Atom equals to tiny neutral particle made of small dense positive nucleus, contains protons and neutrons, holds almost all the mass, electrons orbiting around the nucleus. Typical atomic radius is equivalent to 1 into 10 power minus 10 meters. Nucleus radius is equivalent to 10,000 times smaller than the atom. Let's discuss about Rutherford's alpha scattering. The experiment was about a narrow beam of alpha particle helium 2 plus fired at thin gold foil. The observations and conclusions: most alpha particles passed straight through. It shows atom is mostly empty space. Number 2, some were deflected by small angles. There is a small positive nucleus that repels positive alpha particles. Number 3, a very few bounced straight back, which means that nucleus is tiny and very dense and contains most of the mass. This disproved the plum puddling model and led to the nuclear model of the atom. Now let's discuss about atoms and ions. Atom is a neutral. Number of protons is equals to electrons. Ion is a charged atom or group of atoms. Positive ion atom loses electrons, more protons than electrons. Negative ion means atom gains electron, more electron than proton. Net charge, total positive charge minus total negative charge. Now let's discuss about the nucleus. Nucleus has mass number, atomic number and nuclide notation. Key definition: proton number, which is equals to atomic number, and this is represented by a capital Z. Number of proton in the nucleus defines the element, also equals number of electrons in a neutral atom. Nucleon number, which is represented by capital A, also called as mass number, total number of proton plus neutrons in the nucleus. If you want to calculate number of neutrons, neutrons is equals to A minus Z, which means mass number minus the atomic number. Now we have nuclide notation written as in this form. Above is A, which is mass number, and below you will find Z, which is atomic number. X is element symbol, A is nucleon mass number, and Z is proton atomic number. We have an example of lithium Li over here. The top number 7 represents the mass number, and the bottom one Z represents the atomic number. So if we want to calculate the neutron, we can simply minus 7 minus 3 and we will get the number of neutrons. Now let's discuss about isotopes. Isotopes equals to atom of same element with same proton number and different neutron number. Therefore, same chemical properties but slightly different mass. We have an example of hydrogen isotopes. Protium, which is having 0 neutron, deuterium, which is having 1 neutron, and tritium, which is having 2 neutron. Many isotopes with too many or few neutrons are unstable, most likely to decay, which is radioactive property. Now we discuss about proton, neutrons, and electrons. Relative charge. Using proton charge is equals to plus 1 as a reference. Particle relative charge is proton plus 1, neutron 0 and electron minus 1. Fundamental charge magnitude is about 1.6 times 10 power minus 19 C. You don't need it for calculation here, only concepts are important. Relative mass AMU. Particle relative mass is an approximate value. Proton equals to 1, neutron equals to 1, and electron equals to 1 over 2000. So it's approximately negligible to 0. So the mass of an atom is approximately equal to the mass of nucleus, which is proton plus neutron. Now let's discuss nuclear charge. Nucleus charge depend on number of proton. Nuclear charge is equal to Z times plus 1. For example, in chromium, proton number is 24 and nuclear charge is plus 24. Nuclear mass, relative mass of a nucleus approximately is equals to A, since each proton and neutrons are approximately equals to 1. Example, we have chromium, nucleon number 52 and relative mass also equivalent to 52. Now let's discuss about nuclear fission. Definition. Nuclear fission is the splitting of large unstable nucleus into two smaller nuclei plus 2 to 3 neutron and energy. Typical fission process, example uranium with 235. A slow neutron is absorbed by uranium 235 nucleus. Nucleus becomes unstable and split into two smaller daughter nuclei, 2 or 3 free neutrons. Gamma radiation plus lots of kinetic energy. Example of nuclide equation is uranium 235 plus 1 neutron gives you Kr92 Ba141 and 3 neutron and energy. Conservation checks, you can have nucleon numbers the top part and then you have proton numbers the bottom part. Next we have energy. Total mass of a product is less than total mass of original nucleus plus neutron. Missing mass converted to energy, mass energy equivalence. So fuel for fission reactors, typical U is 235 or Pu is 239. Let's discuss about nuclear fusion. Definition. Nuclear fusion is when two light nuclei join to form a heavy nucleus, releasing energy. For example, in stars, hydrogen nuclei fuse to make helium and energy. And we have a sample equation of this. Deuterium plus hydrogen gives helium 3 and energy. Key points. Mass of a product nucleus is less than total mass of original nuclei and mass converted to energy. Fusion releases more energy per kg of fuel than fission. Needs extremely high temperature and pressure like in stars, very difficult to achieve and contain on Earth. Typical fission neutron question like your word example, if we have given this equation to find n, we need to first find total nucleon number left, which is 236. Then we have total nucleon number right, which is equals to 233 plus n. And then we can equate them to find out the value of n, which is 3. So 3 neutrons are emitted. With this, we have finished our chapter. See you in our next chapter.